Welcome to the Walton Pi. Today we're going to go through two examples of proving the limit of a function is equal to something using epsilon-delta arguments. Alright, let's get started with a fairly straightforward limit. Let's limit as x approaches 3 of 7x minus 9 is equal to 12. So what we're going to have to do is we want to show that for any epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than the absolute value of x minus 3 is less than delta, then absolute value of f of x minus our limit, or in other words, absolute value of 7x minus 12, is going to be less than epsilon. So that's what we're going to be approaching and trying to show. Okay. So first things first, we need to figure out what values we need to take for delta to be given for a given epsilon. So we're going to start with f of x minus L is less than epsilon and try and work our way to figure out what delta we need to pick. So if we look at f of x minus L, that's going to be, as we have written, 7x minus 9 minus 12, which is 7x minus 21, which is the same thing as 7 times x minus 3. The reason we're stopping right here is because this x minus 3 is the same as this x minus 3 over here. And so because of that, we now can say that we can divide, well, specifically, we want this to be less than epsilon. So that means we want to choose x minus 3 to be less than epsilon over 7ths. So we are going to start our proof by saying choose delta to be equal epsilon over 7. So let's go through the proof together. So we are trying to show that the limit as x goes to 3 of 7x minus 9 is equal to 12. So we would start our proof by saying for any epsilon greater than 0, choose delta equal to epsilon over 7. All we have to do is we have to show any epsilon there exists a delta. So by saying delta is this, that is showing that there exists a delta. We now just have to show the rest of this proof. So we would be able to then say assume that 0 is less than the absolute value of x minus 3 is less than delta equals epsilon over 7. So this tells us absolute value of x minus 3 is less than epsilon over 7, which tells us that 7 times absolute value of x minus 3 is less than epsilon. So absolute value of 7x minus 21, which is the same as 7x minus 9 minus 12, that is going to be less than epsilon, which is the same thing as f of x minus L is less than epsilon, which is enough to conclude that the limit as x approaches 3 of 7x minus 9 is in fact 12. Let's go through a slightly more complicated one together then. We're going to do a quadratic this time, so let's look at the limit as x approaches negative 3 of x squared minus 9x plus 2. We want to show that that limit is going to be equal to, let's see, is that going to be this? 38? Yes, that's going to be 38. So let's go through and do this limit together. So again, we're going to want to start out with 0 less than absolute value of x minus negative 3 is less than delta, and we want that to imply that the absolute value of x squared minus 9x plus 2 minus 38 is less than epsilon. So we're going to, again, start with this and try and pull out an x minus negative 3, or in other words, pull out an x plus 3. So let's just start out by looking at the quadratic being less than epsilon. So we got x squared minus 9x plus 2 minus 38. So that's the same thing as x squared minus 9x minus 36. And we want to try and factor out an x plus 3. Let's see, so x plus 3, that would give us an x minus 12 as the other factor. Is that actually going to be valid? Let's see, if we expand that out, we'd get x squared minus 12x plus 3x, so that is a minus 9x and minus 36. So yes, that is how x squared minus 9x minus 36 factors. So this is equal to absolute value of x plus 3 times the absolute value of x minus 12. This to be less than epsilon. Now, the problem with this is we got our x plus 3 here, but we still have to deal with this x minus 12, and we can't just divide by that because x is different for different values. So we have to figure out what values we can choose for that. Maximum delta value is going to come into play. So we are going to insert right here, choose delta to be less than or equal to 1. So I'm just picking 1 as a value. It doesn't have to be 1. We could have picked like 6 or 1/2. Any value works, but choosing delta to be less than or equal to 1 is a fairly standard choice. If delta is less than or equal to 1, then we have to figure out what values can x range between. So we have absolute value of x plus 3 is less than or equal to 1, since it's less than or equal to delta. And so this is going to tell us that x is going to be between -2 and -4. Wait, I have those backwards. It's between -2 and -4, but -2 is bigger than -4. Negatives are confusing with inequalities. So we are going to have x range between those values. We need to figure out which of those is going to make this the biggest. So plugging in -2 would make x minus 12 -14, but if we use -4, that would be a -16. So what we can say is we can guarantee that absolute value of x plus 3 times absolute value of x minus 12, that is going to be less than or equal to absolute value of x plus 3 times absolute value, or not absolute value, we can just do times 16, because that was the largest that absolute value of x minus 12 could be. So if we want that to be less than epsilon, then we are going to say x plus 3 is less than epsilon over 16. So we're not going to just say that delta is equal to epsilon over 16. What we have to do instead is we are going to have to say that delta is the minimum of 1 and epsilon over 16. That's what we're going to be approaching. So if we want to do our proof that the limit as x approaches -3 of x squared minus 9x plus 2 is equal to 38, we are going to start by saying for any epsilon greater than 0, choose delta to be the minimum of 1 and epsilon over 16. Then for all x satisfying 0 less than the absolute value of x minus -3 less than delta equaling the minimum of 1 and epsilon over 16, we can then conclude that that means that x plus 3 is less than epsilon over 16. Well, that tells us that we can conclude that 16 times absolute value of x plus 3 is less than epsilon, which is, so I'm going to rewrite this the other direction, so epsilon comes first, just to make the process a little bit more clear. So that's going to be epsilon is bigger than 16 times absolute value of x plus 3, which is bigger than the absolute value of x minus 12 times absolute value of x plus 3. The reason that we can conclude this part with the 16 is because delta is less than or equal to 1. And that's where we're able to use that jump, as well as the fact that we are close to 3. So we're able to conclude that, which is then equal to the absolute value of x squared minus 9x minus 36, which is equal to x squared minus 9x plus 2 minus 38, which is absolute value of f of x minus L. And we have that as equal to all of this stuff which is less than epsilon, which tells us that the absolute value of f of x minus L is in fact less than epsilon. So we have concluded that the limit as x approaches negative 3 of x squared minus 9x plus 2 is in fact 38. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already, so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.